Trigonometric functions via right triangles. We all know every right triangle has a right angle. That's why it's called right triangle. And then the side opposite to the right triangle is going to be the largest. It's called hypotenuse. And then the other two sides are called legs. So there's one hypotenuse and two legs. If, however, we know one of the acute angles is theta, so let's say this acute angle is theta, then I can label the hypotenuse. Now, with reference to this angle theta, I can label this leg as the opposite side. And this leg as the adjacent side. Now notice that if you have any other right triangle where one of the acute angles is theta, so let me draw a little bit bigger right triangle, but I'll keep one of the acute angles the same. So this angle is theta in this bigger triangle as well. And then this is the hypotenuse in the bigger triangle, and this is the opposite side. And this is the adjacent side. Now the side lengths in these triangles are different, of course. But since they are similar, the ratio of the side lengths will be the same. So if I were to take the ratio of opposite to hypotenuse in this or in this triangle, I'll get the same answer. And this triangle could be even tilted. It does not matter. And that's how the trig functions are defined. They're defined as ratios. The first function is sine of that angle theta. It's defined as the opposite over hypotenuse. So it's opposite over hypotenuse. That's sine theta. Then the second trig function we'll define is cosine theta. And we can write cos theta. It's defined as this ratio, adjacent over hypotenuse. And now we looked at two at a time. So now we might as well look at these two, opposite and adjacent. And that's called tan theta. So tan theta is the ratio of the opposite over adjacent. So we have these three trig functions defined. Notice we are taking two of the side lengths at a time. For sine, it involves opposite and hypotenuse. For cosine, it involves adjacent and hypotenuse. And tan involves opposite over adjacent. A lot of students have this mnemonic to help them remember. So if that helps, you can use it too. So katoa. The first segment is telling me sine is opposite over hypotenuse, and the second one is cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now that we have defined these three trig functions, notice that sine is opposite over hypotenuse. And since hypotenuse is the biggest side, this ratio can never be more than 1. And same thing happens for cosine. You're taking a smaller number and you're dividing by a bigger number. So this ratio will again be not more than 1. Let's put it that way. But tan could be, the opposite could be bigger than the adjacent. So this could be bigger than 1. And this is actually a quite restrictive definition of the trig functions. In a subsequent video, we'll see another definition of trig function via unit circle. There, we can define trig functions for any angle. Now, you might notice in a right triangle, when I'm defining my trig functions this way, I'm assuming that theta is an acute angle, something that's between 0 and 90 degrees. So I cannot I cannot use any other angle besides acute angle if I'm using this definition via right triangles. So let's write down. Now, actually, let's go back to our old sheet and notice sine, cosine, and tan are defined. But if you take this ratio, sine over cosine, that would be opposite over adjacent, which is same as tan. So, before we write that, let me also talk about their reciprocals. So, reciprocals of sine, cosine, and tan are defined as, are said to be okay, so let's write it down. Reciprocals of sine, cos, and tan. Now, it's called cosecant theta. Cosecant theta is 1 over sine theta. Then secant theta is 1 over cosine theta. And the reciprocal of tan is called cot. So cot theta is 1 over tan theta. So usually if you know these three functions, then you automatically know about the other three trig functions, their reciprocals. So for example, we just commented that sine is opposite over hypotenuse. So you're taking a smaller side over larger side. This will be less than 1, which means cosecant will be more than 1. And again, this is quite restrictive, and we may not see that sine theta could be equal to 1 because this is strictly smaller than that. But when we define the unit circle, then we'll see that sine could be 1. Anyway, we'll talk about the domain, range, and all those attributes of these trig functions separately. So at this point, we define our trig functions, sine, cosine, and tan, and we want to define one more equivalence. So tan theta is opposite over adjacent, but this is also equal to sine theta over cos theta. Now, anytime you have an equality of two expressions involving trig functions, you say that it's an identity. So this is one of the trig identities. And there will be a lot of them. We'll see in subsequent videos. So let's go ahead and draw another right triangle. This time I'm going to label my vertices as A, B, and C, and I'll keep the right angle at C. Now, once we label the vertices, we also label the sides. And we don't randomly label whichever way we want. The side opposite to the vertex A, we use lowercase a. And the side opposite to angle B is lowercase b. And then the side opposite to angle C is lowercase c. And so now I can actually define, so let's pick an acute angle. So this, I don't have to call it theta, I can say B. So sine B in this case is opposite over hypotenuse. So it's B over C. And cos B is going to be adjacent, which is A over C. And what do we know? We have this relationship a square plus b square equals c square. Now, if I divide both sides by c square, then I can rewrite the left side of the equation as a square over c square plus b square over c square, and the right side happens to be 1. So notice, what is a square over c square? That's cosine square b. And what is b square over c square? It's actually sine b square, but we sometimes, or not sometimes, that's the usual notation. We write sine square b, but what that means is it's really taking the square of sine b. Here we are taking the square of cosine b. So this is another identity which is quite prevalent. You're going to find it very useful. So cosine square b plus sine square b is equal to 1. Now on the other hand, if I had divided both sides by not c square, but let's say this time we divide by a square. So then the right side becomes c square over a square. You get this time 1 plus b square over a square equal to c square over a square. So that would be 1 plus, what is b over a? B over a is tan b. So let's go ahead and write that as well. Tan b equals b over a. So 1 plus tan square b and c over a. Notice cosine b is a over c. So c over a is its reciprocal. So what's the reciprocal of cosine function? Cosine is here. So 1 over cosine is secant. So I can write this as secant square b. All right. We looked at the Pythagorean theorem and we divided both sides by c square and obtained this identity. Now we divided both sides by a square and obtained this identity. Now we'll divide both sides by b square this time. We already divided by c square, a square, and now let's go ahead and divide by b square and see what we obtain. A square plus b square over c square. Divide both sides by b square. You get a square over b square plus 1 equals c square over b square. So let's go back to our picture and ask what is a over b. Well, tan b is b over a, which means a over b is its reciprocal. What's the reciprocal of tan? It's cot. So I can write this as cot b square or cot square b plus 1 is equal to, what is c square over b square? Well, b over c is sine b. So c over b would have to be its reciprocal. What is the reciprocal of sine? It's cosecant. So this is going to be cosecant square b. Now, so that it looks something like this, let me write this as 1 plus cot square b equals cosecant square b. So here are our three identities, and these are called the Pythagorean identities. What are they? Cos square b plus sine square b. And b happens to be an acute angle. So let me actually write it using theta, and let's put all of them in one place. So cos square theta plus sine square theta is equal to 1. This was our first identity coming from the Pythagorean theorem. The second one is this, which is 1 plus tan square theta equals secant square theta. And then the third one is right here, which is 1 plus cot square theta equals cosecant square theta. These three are called the Pythagorean identities. Now, you definitely want to remember this cosine square plus sine square equals 1. Now, what this is telling me is I'm adding two non-negative numbers. The square of anything is always non-negative, and I'm only getting a total of 1. So that is telling me that each of these must be less than 1. If they are positive, then they both have to lie between 0 and 1. So try to remember this one. These two, the more you use in problems, you'll remember them. Or if needed, you can always derive from this. If you divide both sides by cosine square, you're going to get this identity. And if you divide both sides by sine square, you're going to get this identity. Because tan is sine over cosine. Uh, that's another identity we looked earlier. And this followed from the definition of tan and sine and cosine. So sine and cosine are defined this way. If I took the ratio, then the hypotenuses will cancel in the denominator. I would have opposite over adjacent is equal to tan. So to summarize, we defined trig functions, and we came across this mnemonic to remember the definition of sine, cosine, and tan, SOHCAHTOA. Then we identified that tan is sine over cosine, and then we used Pythagorean theorem to derive these three identities. That's why they're called Pythagorean identities. Trigonometry has a lot of identities, and uh, they all follow from the fundamental definitions, and you want to take one at a time. So with that, let's stop this video for now, and we'll do more in subsequent videos. Thank you.